On November 30th, 2022, something extraordinary happened. There were no fireworks, no worldwide celebration, and no television countdown. Quietly, almost unnoticed by the general public, OpenAI released a conversational artificial intelligence system called ChatGPT. At first, it appeared to be just another experiment in a rapidly evolving field. Yet, beneath that modest launch lay the beginning of one of the most significant technological revolutions in modern history. Within weeks, millions of people were asking questions, writing essays, generating computer code, composing music, and exploring ideas through a machine that responded with remarkable fluency. Then came an astonishing milestone. In only 2 months, ChatGPT surpassed 100 million users, becoming one of the fastest growing consumer applications ever created and shattering records that had previously seemed untouchable. The shockwave spread far beyond Silicon Valley. Inside Google, the company that had dominated internet search for more than 20 years, executives reportedly recognized that a fundamental shift had begun. For the first time in decades, the familiar way billions of people searched for information appeared vulnerable. What had once seemed impossible suddenly became a realistic possibility. The search engine itself could be challenged by a new form of intelligence. But this story is about far more than one chatbot or one company. It is about an unprecedented race for technological supremacy involving the world's most powerful corporations, governments, researchers, and investors. It is a contest measured not only in billions of dollars, but also in influence, knowledge, and the future direction of civilization. In this audiobook, you will journey into the center of the most expensive, intense, and consequential technology war in history, and discover how the outcome may redefine work, creativity, power, and the future of humanity itself. Chapter 1: Code Red at the Googleplex, When the Giant Awakened. Every technological revolution has a moment when the old order realizes that the future has arrived. For Google, that moment was not announced with an explosion. It arrived quietly, through millions of conversations taking place on computer screens around the world. As ChatGPT spread across the internet in late 2022, something extraordinary happened inside Google's headquarters in Mountain View, California. Employees began asking the same unsettling question that was spreading through technology circles everywhere. What if people stop searching and start asking? For more than 20 years, Google Search had been the gateway to the internet. Every day, billions of people typed questions into a simple search box. Google returned links. Users clicked those links. Advertisers paid billions of dollars to appear beside those search results. The model was astonishingly successful. Search advertising became one of the most profitable business models ever created. For decades, it appeared almost invincible. Then, almost overnight, ChatGPT introduced a completely different way of interacting with information. Instead of receiving 10 blue links, users received complete answers. Instead of opening 5 different websites, they could simply continue a conversation. The difference seemed subtle. Its consequences were enormous. Inside Google, executives reportedly recognized that this was not merely another competitor entering the market. It represented a potential shift in how humanity might interact with knowledge itself. Within the company, discussions intensified. Projects that normally moved over months were accelerated, meetings multiplied, resources were reassigned. The situation became serious enough that reports described Google's internal response with 2 words rarely associated with the company: Code Red. Those words carried enormous symbolic weight. Large technology companies do not declare emergencies lightly. Google had survived social networks, it had survived mobile computing, it had survived countless startups promising to replace search. None had fundamentally threatened the foundation of Google's business. This felt different, because ChatGPT was not competing for attention. It was competing for the question itself. That distinction changed everything. For decades, Google had mastered the art of organizing information. Artificial intelligence now appeared capable of synthesizing information instead. The battlefield had moved, and Google suddenly found itself defending territory it had occupied almost alone for a generation. As the pressure mounted, one remarkable event demonstrated just how seriously Google viewed the situation. The company's chief executive, Sundar Pichai, reportedly sought assistance from two people who had largely stepped away from yearly operations: Larry Page, Sergey Brin. The founders, the two graduate students who had transformed a university research project into one of the most influential companies in human history. Although both remained deeply connected to Google's long-term vision, they had spent years focusing on other interests while professional executives managed the company. Now they were back in discussions about the future of artificial intelligence. Their return carried symbolic meaning beyond practical management. It suggested that Google believed the company was entering one of the defining moments of its existence. History often repeats an unusual pattern. When organizations face their greatest uncertainty, they return to their origins. Founders remember why companies were built. They think differently from managers. Managers often protect successful systems. Founders are sometimes willing to replace those systems before someone else does. For Google, this distinction mattered because the challenge was no longer about improving search. It was about imagining a world where search itself might evolve into something fundamentally different. Imagine being responsible for a business that serves billions of users every day while generating enormous revenue from a model perfected over 2 decades. Now imagine realizing that the very technology capable of replacing that model is becoming mature enough to reach the public. Do you embrace it immediately or hesitate, fearing the disruption of your own success? This dilemma would become one of the defining strategic questions of the AI era. Ironically, perhaps the greatest twist in this story began years before ChatGPT ever existed. To understand it, we must travel back to 2017. That year, a group of Google researchers published a scientific paper with an unusually simple title: "Attention is all you need." Research papers rarely become famous outside academic circles. This one changed the entire trajectory of artificial intelligence. Inside that paper was a new neural network architecture called the transformer. Its central insight was elegant. Instead of processing words strictly one after another, a model could learn to pay attention to relationships between many words simultaneously. This mechanism, known as self-attention, dramatically improved the ability of AI systems to understand language, context, and long-range dependencies. At first glance, the innovation appeared highly technical. In reality, it became the foundation for a new generation of language models. Nearly every major breakthrough in modern generative AI traces part of its lineage back to this architecture, including ChatGPT. This is one of the greatest ironies in technology history. The company that invented the underlying architecture was not the company that first transformed it into the defining consumer product. Google possessed many of the world's leading AI researchers. It possessed enormous computing infrastructure. It possessed unparalleled access to data. It possessed financial resources beyond imagination. Yet another organization captured the world's attention first. How could that happen? The answer lies not in engineering alone, but in incentives. Large organizations optimize for the systems that already make them successful, and Google's greatest success was search advertising. Every search query represented an opportunity to display advertisements. Every click generated value. Every improvement in search reinforced an economic engine worth hundreds of billions of dollars. Conversational AI introduced uncertainty into that equation. If an assistant simply provides one comprehensive answer, how many advertisements should appear? How many websites would users still visit? How would publishers survive if fewer people clicked links? Would conversational responses reduce search traffic? Would they change the economics of the open web? These were not hypothetical questions. They touched the foundation of Google's business model. Innovators often describe a concept known as the innovator's dilemma. The paradox is surprisingly simple. The better a company becomes at one successful model, the harder it becomes to replace that model voluntarily. Disruption rarely begins because established companies lack intelligence. It begins because they have powerful reasons to protect what already works. History offers many examples. Photography companies hesitated before embracing digital cameras. Video rental businesses underestimated streaming. Mobile phone leaders dismissed smartphones. In many cases, the technology itself was visible long before the market shifted. What delayed change was not ignorance. it was success. Google's situation unusually complex because it faced the possibility of disrupting itself. Should it aggressively deploy conversational AI and risk reducing revenue from traditional search? Or should it move cautiously while others experimented? There was no obvious answer. Every option carried enormous risks. Move too slowly, and competitors gain momentum. Move too quickly, and you may undermine your own business before understanding the consequences. Leadership in technology often appears glamorous from the outside. In reality, it frequently consists of choosing between two dangerous alternatives. Meanwhile, the public saw only the visible outcome. ChatGPT continued attracting users. Developers built applications. Businesses experimented with automation. Students explored new ways of learning. Writers, programmers, teachers, designers, scientists, and entrepreneurs all began discovering unexpected possibilities. Artificial intelligence was no longer confined to research laboratories. It had entered daily life. Google responded rapidly. Existing AI projects accelerated. Large language models that had been under development gained new urgency. Engineers worked to integrate generative AI into products used by billions. The competition had officially begun. But beneath the race between companies lay an even larger transformation. For decades, internet search had been built around discovering information created by humans. Generative AI introduced a different paradigm. Machines could now generate explanations, summarize research, write software, translate languages, create images, and assist with increasingly complex reasoning tasks. The interface between humans and knowledge was evolving. Search was becoming conversation. Information retrieval was becoming collaboration. This shift may ultimately prove more significant than the arrival of the smartphone or the rise of social media, because language is the operating system of human civilization. Every law, every scientific paper, every business contract, every novel, every classroom lecture, every political speech depends upon language. A machine capable of understanding and generating language at scale has the potential to influence nearly every profession built upon information. That realization explains why Google's response became so urgent. This was never merely a competition between two technology companies. It was the opening chapter of a struggle over the future architecture of human knowledge itself. And like many turning points in history, the revolution did not begin with a loud explosion. It began with a quiet conversation between a human and a machine. Chapter 2: OpenAI and the Beginning of a Dangerous Alliance. Every great technological revolution begins with a promise. Sometimes that promise is prosperity, sometimes it is freedom, and sometimes it is protection from a danger that does not yet exist. The story of OpenAI began with exactly such a promise. Long before ChatGPT became a household name, long before governments debated AI regulation, long before investors poured hundreds of billions of dollars into artificial intelligence, a small group of entrepreneurs and researchers gathered around a troubling question. What would happen if artificial intelligence became more powerful than humanity was prepared to handle? At the time, this concern sounded almost like science fiction. The year was 2015. Deep learning was advancing rapidly, but artificial intelligence still struggled with tasks that modern systems now perform routinely. Most people viewed AI as a specialized technology. Few imagined it would soon become the center of a global race involving governments, corporations, and national security agencies. Yet some individuals saw further ahead. Among them were entrepreneurs, engineers, scientists, and investors who believed humanity might be approaching a technological turning point unlike anything in history. Their concern was not that AI would fail. Their concern was that AI might succeed. Too well. If a small number of companies gained control over increasingly powerful artificial intelligence systems, the consequences could affect every aspect of society: economic power, political influence, scientific progress, military capability, human autonomy itself. The founders believed such transformative technology should not belong exclusively to a handful of corporations. And so, OpenAI was born. When OpenAI was announced in December 2015, its mission sounded radically different from that of a traditional technology startup. Most startups exist to maximize profits. OpenAI claimed something much larger. Its goal was to ensure that advanced artificial intelligence would benefit all of humanity. the organization was initially established as a nonprofit. This decision was not merely symbolic. It reflected a philosophical position. If artificial intelligence eventually became one of the most powerful technologies ever created, then perhaps it should not be governed solely by shareholder interests. Perhaps research should be shared. Perhaps breakthroughs should be distributed widely. Perhaps humanity should cooperate rather than compete. At least, that was the vision. The announcement attracted enormous attention. Some of the most influential figures in technology supported the project. Researchers left prestigious institutions to join. Funding commitments reached hundreds of millions of dollars. For a brief moment, OpenAI appeared to represent an alternative future for artificial intelligence, one built on openness rather than secrecy, collaboration rather than competition, safety rather than speed. But history has a habit of testing ideals, and the greater the technology, the greater the pressure. Among the most prominent supporters of OpenAI in its early days was a man who rarely stays out of transformative industries, Elon Musk. By 2015, Musk had already become one of the world's most recognizable entrepreneurs. Through Tesla, he was attempting to transform transportation. Through SpaceX, he was attempting to transform space exploration. And through numerous public statements, he repeatedly warned about the long-term risks of artificial intelligence. Unlike many technology leaders, Musk openly discussed the possibility that advanced AI could someday become a threat if developed irresponsibly. He described artificial intelligence as one of humanity's greatest challenges. In his view, waiting until powerful systems already existed would be dangerously late. OpenAI's mission aligned closely with those concerns. Musk became one of the organization's most visible backers. His involvement attracted attention, credibility, and resources. For many observers, his presence signaled that OpenAI was serious about its safety-oriented mission. But another figure was equally important, perhaps even more important. His name was Sam Altman. At the time, Altman was already respected throughout Silicon Valley as an investor, entrepreneur, and former president of the influential startup accelerator Y Combinator. Unlike Musk, who often commanded headlines through bold public statements, Altman cultivated a reputation for strategic thinking and long-term vision. He became one of OpenAI's key architects. If Musk embodied urgency, Altman embodied execution. Together, they represented two different philosophies united by a common concern. Both believed artificial intelligence would become enormously important. Both believed society was underestimating its impact. Both wanted to shape its future. Yet beneath that agreement, differences gradually emerged. Building advanced AI turned out to be vastly more expensive than many people anticipated. Training increasingly powerful models required enormous computational resources. Researchers needed cutting-edge hardware. Data centers consumed staggering amounts of electricity. Engineering teams expanded. Costs accelerated. Every breakthrough demanded even greater investment. The original nonprofit vision encountered a harsh economic reality. Artificial intelligence was becoming one of the most capital-intensive industries in history. A difficult question emerged. How could OpenAI remain true to its mission while competing against technology giants with virtually unlimited resources? Google possessed massive infrastructure. Meta possessed enormous research teams. Amazon possessed global cloud computing networks. OpenAI possessed talent and ambition. But ambition alone does not pay for supercomputers. Inside the organization, discussions intensified. Should OpenAI remain strictly nonprofit? Should it seek outside capital? Should it adopt a hybrid structure capable of attracting major investment? These debates reflected a deeper tension that has accompanied technological progress throughout history. Can idealism survive contact with reality, or must ideals adapt in order to survive? During this period, disagreements reportedly emerged regarding OpenAI's future direction. The precise details remain subjects of debate and interpretation. But one fact is clear. Elon Musk eventually left. In 2018, he stepped away from OpenAI's leadership. Public explanations reference potential conflicts of interest, particularly given Tesla's growing involvement in artificial intelligence. Yet observers have long speculated that broader strategic disagreements also played a role. Some reports suggested differing views regarding organizational structure. Others suggested disagreements about how aggressively OpenAI should pursue advanced AI development. Whatever the combination of reasons, the result was significant. One of OpenAI's most influential founders was gone. At the time, few realized how consequential that departure would become. Years later, Musk and OpenAI would find themselves on opposite sides of one of the most important debates in modern technology, but that chapter had not yet been written. For now, OpenAI faced a more immediate challenge. It needed resources, massive resources, and only a handful of organizations on Earth could provide them. That reality set the stage for one of the most consequential partnerships in technology history, the alliance between OpenAI and Microsoft. To understand its significance, imagine two organizations standing at very different crossroads. OpenAI possessed world-class AI talent and ambitious research goals. Microsoft possessed capital, infrastructure, and one of the largest cloud computing platforms on Earth. Each needed something the other could provide. For Microsoft's chief executive, Satya Nadella, the opportunity was enormous. Since becoming CEO in 2014, Nadella had transformed Microsoft's culture and strategic direction. Cloud computing became central to the company's future. Artificial intelligence represented the next frontier. Rather than treating AI as a side project, Nadella recognized its potential to reshape nearly every software product Microsoft offered. Productivity tools, cloud services, programming platforms, search engines, enterprise software, everything. OpenAI offered access to the cutting edge of that future. For OpenAI, Microsoft offered something equally valuable, the ability to scale, not gradually, exponentially. In 2019, the relationship deepened dramatically. Microsoft invested approximately $1 billion in OpenAI. At the time, the number seemed astonishing. Soon, it would appear modest compared to what followed. The partnership expanded over subsequent years. Investments grew, infrastructure commitments grew, computational resources grew. The alliance became increasingly intertwined. What emerged was far more than a financial arrangement. It became a strategic partnership capable of reshaping the entire AI industry. Yet this moment also represented a profound philosophical transformation. The nonprofit organization founded to ensure artificial intelligence would benefit humanity now relied on one of the world's largest corporations for survival and growth. Critics saw contradiction. Supporters saw necessity. Both perspectives contained elements of truth. Without enormous funding, OpenAI might never have developed the systems that later transformed the world. Without those resources, ChatGPT might never have reached hundreds of millions of users. At the same time, dependence on billions of dollars inevitably changes incentives. Money creates possibilities. It also creates obligations. This tension lies at the heart of the modern AI era. Artificial intelligence requires unprecedented resources. Those resources are concentrated among a small number of powerful institutions. As a result, even organizations founded on ideals eventually confront practical realities. The dream of openness collides with competitive pressure. The desire for safety collides with the race for innovation. The mission to serve humanity collides with the economics of building intelligence at planetary scale. OpenAI's partnership with Microsoft symbolized all of these contradictions. It was a marriage of vision and capital, of research and infrastructure, of idealism and pragmatism. Some viewed it as the only path forward. Others viewed it as the moment a movement became an industry. History may ultimately decide which interpretation is correct, but one fact is undeniable. The alliance changed everything. With Microsoft's resources behind it, OpenAI gained the ability to compete with technology giants once thought untouchable. The balance of power in Silicon Valley began to shift. The foundations of the AI race were being laid. And what had started as a nonprofit effort to protect humanity from the risks of artificial intelligence was slowly evolving into something much larger. A global struggle for technological leadership, a contest involving trillions of dollars in future economic value, a race that would soon draw in every major technology company on Earth. The dangerous alliance had been forged, and the war for artificial intelligence was only beginning. Chapter 3, Inside the AI Brain, the Power of Large Language Models. Imagine walking into the largest library ever conceived. Not a library containing millions of books, but billions of documents, books, newspapers, scientific papers, computer code, poetry, history, conversations, recipes, legal documents, encyclopedias, movie scripts, public websites, research articles, countless fragments of human thought recorded across decades of the digital age. Now imagine asking someone to read every page, not to memorize every sentence exactly, but to discover the hidden patterns beneath language itself. How words connect, how ideas flow, how questions usually lead to answers, how stories begin and how they end. That, in simplified form, is how a modern large language model, often called an LLM, is created. It is one of the greatest engineering achievements in human history, and at the same time, one of the most misunderstood. Many people imagine ChatGPT as a gigantic database that searches for the correct answer before replying. It is not. Others imagine that it possesses consciousness, emotions, or secret knowledge hidden somewhere inside a digital mind. It does not. The reality is both less magical and somehow even more astonishing. Before an AI can answer questions, write essays, translate languages, or generate computer code, it must first learn the statistical structure of human language. This process begins with an unimaginably large collection of text. The model is exposed to books, publicly available articles, academic publications, programming languages, reference materials, and many other forms of written communication. It does not read these materials the way a human student reads a textbook. There is no curiosity, no awareness, no moment of inspiration. Instead, the text is converted into tiny units called tokens. A token may represent an entire word, sometimes only part of a word, sometimes punctuation. Even spaces and symbols become meaningful pieces of information. To a language model, language becomes mathematics. Every token is transformed into numbers. Those numbers become vectors. Those vectors occupy positions inside a vast multidimensional mathematical space where relationships between ideas begin to emerge. Words that frequently appear together gradually become closer. Concepts sharing similar meanings develop related patterns. Without anyone explicitly defining grammar or teaching vocabulary, the model slowly discovers the statistical architecture of language. It learns that Paris is often associated with France, that doctors work in hospitals, that equations follow mathematical rules, that novels have chapters, that questions often end with question marks. No programmer manually writes millions of these relationships. They emerge from the data itself. The learning process involves making billions upon billions of predictions. A sentence appears. One token is hidden. The model attempts to guess what should come next. If it predicts incorrectly, its internal parameters adjust ever so slightly. Then it tries again and again, trillions of times. Each tiny correction improves the system's ability to predict language. Eventually, after enough computation, something remarkable happens. The model begins generating coherent sentences, then paragraphs, then explanations, then computer programs, then poetry, then conversations that often feel surprisingly human. Not because someone programmed every possible response, but because the model has absorbed statistical patterns from an enormous portion of written human knowledge. This leads us to one of the most surprising truths about artificial intelligence. Despite appearances, an LLM does not think the way humans think. When people converse, they draw upon memories, emotions, sensory experiences, beliefs, intentions, and conscious awareness. We understand what rain feels like. We remember childhood experiences. We recognize the smell of coffee. We understand pain not merely as a concept, but as something lived. A language model has none of these experiences. It has never seen a sunrise, never touched water, never tasted food, never feared failure, never celebrated success. Yet it can describe all of these experiences with astonishing fluency. How? Because its fundamental task is astonishingly simple. Predict the next token. Everything else emerges from that single objective. When you type a prompt into ChatGPT, the model is not searching for the answer, hidden somewhere inside a database. Instead, it continuously estimates probabilities. Given everything that has already appeared in the conversation, what token is most likely to come next? Then, after generating that token, what comes next, and then the next, and the next. Millions of calculations occur in fractions of a second. The resulting sentence feels intentional. Yet underneath, it is an extraordinarily sophisticated chain of probability estimates. At first glance, this sounds almost disappointing. Surely human conversation must involve something more profound than prediction. And it does. But here's the astonishing discovery that surprised even many AI researchers. Prediction itself can become extraordinarily powerful. Imagine predicting every word of every sentence so accurately that entire essays emerge naturally. Imagine predicting computer code accurately enough to build software. Imagine predicting medical terminology well enough to summarize research papers. Imagine predicting dialogue well enough that millions of people forget they are speaking to a machine. The boundary between prediction and understanding suddenly becomes difficult to define. Researchers continue debating exactly what large language models truly understand. Some argue they merely manipulate symbols. Others believe sufficiently advanced prediction gives rise to forms of abstract reasoning that resemble aspects of understanding. The debate remains unresolved. What is clear, however, is that today's systems demonstrate capabilities few experts predicted would emerge so rapidly. They solve mathematical problems, explain scientific concepts, translate dozens of languages, generate software, compose music, draft legal documents, assist researchers, tutor students, brainstorm inventions. None of these abilities were programmed individually. They emerged from learning the patterns embedded within language itself. This phenomenon is often called emergent behavior. Complex abilities arising from relatively simple learning objectives once sufficient scale is achieved. It remains one of the most fascinating mysteries in modern artificial intelligence. Yet for all their extraordinary capabilities, large language models possess a weakness that reveals their fundamentally different nature. Researchers call it AI hallucination. The name is dramatic. The reality is even more fascinating. Imagine asking a highly confident professor about a historical event. The professor immediately responds with precise dates, specific names, convincing quotations, detailed explanations. Everything sounds perfectly reasonable, except none of it actually happened. The citations are fictional. The people never existed. The quotations were invented. This is not lying. Lying requires awareness of truth. A language model possesses no such awareness. Instead, it generates text that statistically resembles the kind of answer humans would expect. Most of the time, this produces accurate information. Sometimes, it produces elegant fiction disguised as fact. Why does this happen? Because the model's objective is not to verify reality. Its objective is to predict plausible language. Suppose you ask for a scientific paper on a highly specialized topic. If the model has incomplete information, it may generate a title that looks authentic. It may invent authors whose names fit the field. It may fabricate a journal with a believable volume number. Every component follows recognizable patterns. The overall result appears convincing. Yet the paper itself does not exist. From the model's perspective, nothing unusual has occurred. It simply continued predicting probable text. Humans experience this as hallucination. The machine experiences only mathematics. This distinction has profound implications. Confidence does not guarantee correctness. Fluency does not equal truth. Beautiful prose can still contain false information. As language models improve, this challenge becomes even more subtle. Early AI systems often produced obviously incorrect answers. Modern systems produce mistakes that can be extraordinarily difficult to detect, especially when discussing unfamiliar subjects. This is why experts emphasize that AI should often be viewed as a powerful assistant rather than an unquestionable authority. Verification remains essential, especially in medicine, law, scientific research, engineering, finance, and any field where factual accuracy carries serious consequences. Ironically, hallucinations also teach us something important about human intelligence. People often assume memory works like a video recording. Neuroscience suggests otherwise. Human memory is reconstructive. Each time we remember an event, our brains actively rebuild it. Details may change. Confidence may exceed accuracy. Eyewitness testimony can be surprisingly unreliable. Humans, too, sometimes generate convincing narratives that differ from objective reality. The difference is that we possess additional tools. We can check external evidence, consult other people, recognize contradictions, reflect upon our own uncertainty. Large language models lack these independent mechanisms unless connected to external systems designed to retrieve and verify information. In other words, AI does not naturally know when it does not know. That may be one of the greatest challenges researchers continue working to solve. Despite these limitations, the emergence of large language models represents a profound turning point in technological history. For the first time, machines can interact with human language not through rigid commands, but through conversation. They can explain, summarize, translate, reason across complex topics, generate creative ideas, and collaborate with people in ways once confined to science fiction. Yet, beneath every elegant paragraph, every insightful explanation, every line of generated code, lies an astonishingly simple engine. Not consciousness, not imagination, not human thought, prediction, billions of mathematical relationships refined through unimaginable amounts of computation, and intelligence built not from experience but from probability. Whether future AI systems will evolve beyond this paradigm remains one of the greatest unanswered questions of our age. But one fact is already clear. The ability to predict language with extraordinary precision has changed the world, and humanity is only beginning to discover what that truly means. Now, Chapter 4, Bard's Counterattack and the $100 billion media disaster. History rarely gives powerful companies the luxury of time. When a disruptive technology appears, every day spent waiting feels like a week, every week feels like a month, and every month may allow a rival to reshape an entire industry. That was the reality facing Google in the months following ChatGPT's explosive rise. For years, Google had been widely recognized as one of the world's leading artificial intelligence research organizations. Its scientists had published groundbreaking papers. Its engineers had built some of the most advanced machine learning systems ever created. Millions of people already interacted with Google's AI every day, often without realizing it, through search, translation, maps, photos, and countless other services. Yet public perception had changed with astonishing speed. To much of the world, artificial intelligence suddenly had a new face. ChatGPT, the company that had invented many of the underlying technologies, now appeared to be chasing a competitor that had captured the world's imagination. Silicon Valley understands one rule better than almost anywhere else: perception matters. Sometimes it matters nearly as much as reality. Google could not afford to appear passive. The giant had to respond, and it had to respond quickly. The answer arrived with a name inspired by ancient storytellers: Bard. The choice was symbolic. In many cultures, a bard is a poet, a narrator, a keeper of stories. The message was clear. Google's artificial intelligence would not simply retrieve information. It would communicate. It would explain. It would create. Internally, Bard drew upon years of Google's research into large language models, including technologies developed from projects such as Lambda and other advanced conversational systems. This was not a product built from nothing. It represented years of accumulated scientific work finally reaching the public. But there was a problem: timing. Google was no longer launching from a position of calm confidence. It was launching under pressure. The technology industry had entered an arms race. Every announcement was scrutinized, every demonstration compared, every delay interpreted as weakness. Investors wanted reassurance, developers wanted innovation, journalists wanted headlines, competitors wanted mistakes. Launching revolutionary technology under those conditions is extraordinarily difficult, because no matter how advanced the system, the world is often waiting for the first error. Google organized a public demonstration intended to show that Bard could compete with the rapidly growing wave of conversational AI. The event was carefully prepared. Marketing teams refined the presentation. Engineers tested the product. Executives emphasized the company's decades of AI leadership. The objective extended beyond introducing a new chatbot. It was about restoring confidence. The message was straightforward. Google was still a leader. Google was still innovating. Google was still prepared for the future. Then something happened that no communications team ever wishes to experience. During promotional material associated with Bard's introduction, the system answered a question about discoveries made by the James Webb Space Telescope. The response included a factual claim that was later challenged by astronomers and science observers. Specifically, Bard suggested that the James Webb Space Telescope had captured the first images of a planet outside our solar system. The statement sounded reasonable. It was delivered confidently. It even appeared educational. There was only one problem: it was incorrect. Astronomers quickly pointed out that images of exoplanets had been obtained years before the James Webb Space Telescope began operations. The mistake spread across news organizations almost immediately. On the surface, the error appeared relatively small. After all, humans make factual mistakes every day. Scientists publish corrections, journalists issue updates, teachers occasionally misspeak. No one expects perfection. So, why did this particular mistake become so significant? Because context changes the meaning of every event. Google was not merely introducing another software product. It was attempting to demonstrate that its artificial intelligence could compete with the fastest growing AI platform in history. The demonstration itself was meant to inspire confidence. Instead, it created doubt. The irony was impossible to ignore. Only weeks earlier, the technology industry had been discussing the remarkable capabilities of generative AI. Now the headlines focused on one incorrect sentence. This illustrates a fascinating principle of human psychology. People often remember failure more vividly than success. 1,000 accurate answers disappear into the background. One highly visible mistake becomes front-page news. Artificial intelligence magnifies this effect because society instinctively expects computers to be precise. When humans make errors, we forgive them. When machines make errors, we question the entire technology, especially when those machines claim to assist with knowledge itself. Bard's mistake therefore became much larger than astronomy. It became symbolic. Commentators asked uncomfortable questions. Was Google rushing its product? Had competitive pressure overtaken careful engineering? Was conversational AI truly ready for widespread public use? None of these questions could be answered by a single incorrect fact. Yet perception often evolves faster than evidence. The narrative had begun to shift. Financial markets reacted with extraordinary speed. Stock markets are often described as voting machines in the short term and weighing machines in the long term. Investors constantly evaluate expectations, not only what a company has achieved, but what they believe it will achieve tomorrow. When confidence changes, market value can change almost instantly. Following concerns surrounding Bard's introduction, shares of Alphabet, Google's parent company, experienced a significant decline. The movement erased roughly $100 billion in market capitalization in a single trading session. $100 billion. It is a number so enormous that the human mind struggles to visualize it. It exceeds the annual economic output of many nations. It could finance massive infrastructure projects, fund thousands of scientific laboratories, support millions of university scholarships. Yet, financial markets can create or erase such value within hours. Did Google's factories disappear overnight? No. Did its engineers suddenly become less talented? No. Did billions of people stop using Google Search the next morning? Again, no. The company's physical assets remained. Its research capabilities remained. Its global infrastructure remained. What changed was expectation. Investors began reassessing the future. If artificial intelligence altered the economics of search, how valuable would Google's dominant position remain? If Microsoft successfully integrated OpenAI's technology into its own products, could competitive dynamics change faster than previously imagined? If Google appeared to be reacting rather than leading, would future growth slow? Markets do not wait for certainty. They price possibility, sometimes accurately, sometimes emotionally, often both. This episode revealed an uncomfortable truth about the AI revolution. Artificial intelligence is no longer evaluated solely by engineers. It is evaluated simultaneously by consumers, journalists, politicians, regulators, investors, and billions of ordinary users. Every public demonstration carries multiple audiences. An engineer may see a system that performs correctly 99% of the time. A financial analyst may see strategic positioning. A journalist may see a headline. A regulator may see societal risk. A consumer may remember only one spectacular mistake. The technology itself becomes only part of the story. Communication becomes equally important. Managing expectations becomes equally important. Trust becomes equally important. To Google's credit, the company did not retreat. Instead, it accelerated. Engineers continued improving Bard. Researchers refined the underlying models. Safety systems expanded. Capabilities increased. Eventually, Google made another significant decision. The Bard brand would be retired. Its AI efforts would instead be unified under a new name, Gemini. The rebranding represented more than marketing. It reflected Google's ambition to build an AI ecosystem extending beyond simple conversation. Text, Images, audio, video, programming, reasoning, multimodal intelligence capable of working across many forms of information. The competition had entered a new phase, no longer chatbot versus chatbot, now platform versus platform, ecosystem versus ecosystem, long-term vision versus long-term vision. Perhaps the greatest lesson from Bard's difficult debut concerns the nature of innovation itself. History often remembers successful products as inevitable. In reality, breakthroughs almost always emerge through imperfect beginnings. The first automobiles frequently broke down. Early airplanes crashed. The earliest smartphones lacked many features we now consider essential. Even the internet itself was once dismissed as impractical by respected observers. Technological revolutions rarely unfold in straight lines. They advance through experiments, corrections, embarrassments, unexpected failures, relentless improvement. Artificial intelligence is following the same pattern. Every public mistake exposes weaknesses researchers must solve. Every limitation reveals new scientific questions. Every failure becomes data, and in engineering, data is progress. Still, the $100 billion episode remains one of the defining moments of the AI race. Not because Bard answered one astronomy question incorrectly, but because the incident demonstrated how much was already at stake. This was no longer a competition for better software. It was a struggle over the future of information itself. The company that earned public trust would influence how billions of people learned, searched, created, and made decisions. Confidence had become a strategic asset. Accuracy had become a financial asset. Trust had become an economic asset. In previous technological eras, a flawed product demonstration might have embarrassed a company. In the age of artificial intelligence, it could reshape global market expectations overnight. Google recovered. Its research continued. Gemini evolved into an increasingly capable family of AI models. The race moved forward, but the lesson endured. When the world is watching, one sentence can move markets. One mistake can alter narratives. And in the age of artificial intelligence, a few misplaced words can carry a price measured not in millions, but in $100 billion. Chapter 5, The Hardware Gold Rush, Nvidia's Silent Empire. When people imagine artificial intelligence, they usually picture software. They imagine elegant conversations with chatbots, images created from simple text prompts, programs that write code, virtual assistants that answer questions in seconds. What they rarely imagine is electricity, warehouses filled with servers, miles of networking cables, cooling systems running day and night, and countless silicon chips performing trillions upon trillions of calculations every second. Yet beneath every spectacular AI breakthrough lies a simple truth. Artificial intelligence is not powered by magic. It is powered by computation, and computation demands hardware. The modern AI revolution is often described as a software revolution. In reality, it is equally a hardware revolution, perhaps even more so, because no matter how brilliant an algorithm may be, it cannot learn without enough computing power to train it. In the race for artificial intelligence, ideas matter. Talent matters. Capital matters. But sooner or later, everything runs into the same physical limitation. How many calculations can your machines perform? That question has become one of the defining strategic challenges of the 21st century. Training a modern large language model is unlike almost any computational task humans have attempted before. Imagine asking a computer to predict the next word. Not 1,000 times, not 1,000,000 times, but trillions of times. Each prediction requires billions of mathematical operations. Each correction adjusts billions or even hundreds of billions of numerical parameters. The process continues for weeks, sometimes months. Thousands of specialized processors work simultaneously across enormous data centers. Every second, they exchange information through ultra-fast communication networks. Every second, they consume vast amounts of electricity. Every second, they generate enormous heat that must be removed before the hardware overheats. Building a frontier AI model is therefore not merely a scientific challenge. It is an industrial challenge, an energy challenge, an infrastructure challenge. This is why many experts argue that the AI race is, at its core, a competition for computational capacity. The countries capable of producing the most advanced chips, building the largest data centers, and generating sufficient electrical power may enjoy significant strategic advantages in artificial intelligence. Computation has become a new form of industrial power. Just as coal fueled the Industrial Revolution and oil fueled the 20th century, computing power is becoming one of the defining resources of the AI age. For decades, one company quietly positioned itself at the center of this transformation, not through flashy consumer products, not through dominant social media platforms, not through search engines, but through a component most ordinary people never purchase directly: the graphics processing unit, the GPU. To understand why GPUs became so important, imagine trying to move an entire mountain with a single worker. No matter how skilled that worker may be, progress will be slow. Now imagine employing thousands of workers simultaneously. Each moves a small amount of material. Together, they accomplish in hours what one individual might require years to complete. This is the philosophy behind modern GPUs. Traditional central processing units, or CPUs, excel at handling a wide variety of different tasks. They are versatile, flexible, general purpose. GPUs, by contrast, were originally designed to perform many similar mathematical operations at the same time. Their first major purpose was rendering computer graphics. Millions of pixels, countless calculations, parallel processing. For years, gamers eagerly purchased increasingly powerful graphics cards to experience more realistic virtual worlds. Few realized that these same chips possessed another remarkable ability. They were extraordinarily effective at training neural networks. Researchers gradually discovered that GPUs could accelerate machine learning dramatically. Tasks that once required weeks could suddenly be completed in days, later in hours. A technology built for video games unexpectedly became the engine of artificial intelligence. History is filled with such accidents. The internet was not originally designed for social media. GPS was not created for food delivery. And GPUs were not invented to build conversational AI. Yet innovation often emerges when existing technologies find entirely new purposes. No one benefited more from this unexpected shift than Nvidia. Founded in 1993, the company spent decades competing in the graphics market. Its products became favorites among gamers, designers, scientists, and engineers. But long before artificial intelligence captured global headlines, Nvidia's leadership recognized a deeper opportunity. At the center of that vision stood one remarkable figure: Jensen Huang. Always recognizable in his signature black leather jacket, Huang became one of the most influential technology leaders of the AI era. Unlike many executives who reacted after artificial intelligence became fashionable, Huang had spent years investing in technologies that many observers initially underestimated. He believed accelerated computing would transform industries far beyond gaming. Scientific simulation, medical research, autonomous vehicles, robotics, climate modeling, artificial intelligence. One by one, those predictions began coming true. Nvidia did not merely sell chips, it built an ecosystem: programming tools, software libraries, developer platforms, networking technologies, optimization frameworks. This ecosystem created an enormous advantage. Engineers training AI models learned Nvidia's software. Universities taught Nvidia's programming environment. Companies optimized their systems around Nvidia hardware. The result was powerful network effects. The more developers used Nvidia, the more valuable the platform became. And the more valuable the platform became, the harder it became for competitors to replace it. By the time generative AI exploded into public awareness, Nvidia occupied an extraordinary position. Industry estimates suggested that the company supplied the overwhelming majority of GPUs used for training cutting-edge AI models, often described as around 90% of that specialized market. This dominance was not the result of one lucky product. It reflected decades of engineering, software development, and strategic patience. The company many people once associated primarily with gaming had quietly become one of the most important infrastructure providers of the AI revolution. Jensen Huang was often described as the kingmaker of artificial intelligence, not because he controlled the algorithms, but because nearly everyone needed his hardware. Then came the chip that became almost mythical: the H100. To the average consumer, the name means very little. To AI researchers, it became one of the most valuable pieces of hardware on Earth. The H100 represented far more than another graphics processor. It was optimized specifically for demanding artificial intelligence workloads, training large language models, running complex inference, accelerating scientific computation. Its performance dramatically reduced the time required for many AI tasks. In an industry where speed determines competitive advantage, time is money. Sometimes, billions of dollars. Imagine two companies attempting to build the next generation of AI. One completes training in 3 months. The other requires 6. The faster company can experiment sooner, improve sooner, launch sooner, capture users sooner. The value of computational speed compounds rapidly. Owning enough advanced GPUs therefore became a strategic necessity rather than a luxury. Demand exploded, supply struggled to keep pace. Waiting lists grew longer, prices increased. Entire data centers were planned around future GPU deliveries. Technology executives spoke openly about computation as one of the greatest constraints on AI progress. The challenge was no longer finding talented researchers, it was finding enough chips. The shortage transformed advanced semiconductors into geopolitical assets. Governments paid close attention. Technology companies negotiated enormous purchase agreements. Cloud providers expanded infrastructure at unprecedented speed. The world's largest corporations competed fiercely for access to advanced computing resources. Reports emerged of organizations reserving GPU capacity months, sometimes years, in advance. Some companies redesigned product timelines around hardware availability. Others invested directly in new data centers simply to prepare for future shipments. In diplomatic circles, advanced semiconductors increasingly became part of broader strategic conversations surrounding technology leadership, supply chains, and national competitiveness. The AI race had expanded far beyond software laboratories. It now involved manufacturing, international trade, energy infrastructure, semiconductor fabrication, global logistics, even foreign policy. A single shipment of advanced chips could influence research schedules worth billions of dollars. The hardware itself had become strategic capital. Yet another irony lies beneath this story. Artificial intelligence is often portrayed as purely digital, weightless, invisible, existing somewhere inside the cloud. But clouds do not think, computers do, and computers occupy physical space. Every AI conversation passes through real processors, real memory chips, real fiber optic cables, real cooling systems, real power stations. Behind every elegant response generated by an AI assistant stands an enormous industrial ecosystem. Mining companies extract rare minerals, engineers design transistors measured in nanometers, factories manufacture semiconductors under astonishing precision, cargo ships transport components across oceans, technicians assemble servers, electric utilities deliver power, network engineers maintain global infrastructure. Artificial intelligence may appear intangible. Its foundation is profoundly physical. The hardware gold rush continues today. Technology companies invest hundreds of billions of dollars in computing infrastructure. New semiconductor designs emerge. Competitors challenge Nvidia's leadership. Custom AI accelerators are developed by several major technology firms. Governments encourage domestic chip manufacturing. Researchers search for more efficient algorithms requiring fewer computational resources. The race has only begun. Whether Nvidia will maintain its extraordinary position over the coming decades remains uncertain. History reminds us that every technological empire eventually faces new challengers, but one achievement is already undeniable. By recognizing the importance of accelerated computing long before much of the world appreciated its significance, Nvidia transformed itself from a graphics company into one of the central pillars of the artificial intelligence revolution. The lesson extends far beyond semiconductors. Technological revolutions are rarely won solely by the inventors of brilliant ideas. They are also won by those who build the machines capable of turning those ideas into reality. In the age of artificial intelligence, silicon has become strategic. Electricity has become a competitive advantage. Computation has become a new measure of national power, and somewhere inside vast data centers humming day and night, countless GPUs continue performing silent calculations, powering the algorithms that may shape the future of civilization. The world's attention often focuses on the intelligence we can see, but the real battle may be taking place deep inside the machines that make that intelligence possible. Chapter 6: The Valley of Truth Distorted: The Rise of the Deepfake Generation. For thousands of years, humanity relied on a simple principle: Seeing was believing. If your eyes witnessed an event, it probably happened. If you heard someone's voice, they were likely speaking. If a photograph existed, it was treated as evidence. If a video captured a moment, it became part of history. Civilizations built courts around eyewitness testimony. Journalists built credibility around photographs. Historians preserved films as records of reality. Our senses were never perfect. People could misunderstand, memories could fade, images could be manipulated, but the cost of convincing deception was extraordinarily high. Creating a believable fake photograph once required specialists. Producing a convincing fake video demanded expensive equipment, skilled editors, and enormous amounts of time. In other words, truth possessed a natural advantage. Reality was easier to produce than fiction. Artificial intelligence is changing that equation. Perhaps for the first time in human history, creating convincing fiction may become easier than documenting reality. And that possibility reaches far beyond technology. It challenges one of the deepest assumptions upon which modern society is built. The first wave of generative AI astonished the world through words. Large language models demonstrated that machines could generate essays, poems, software, conversations, and explanations with remarkable fluency. People wondered whether AI could write. Soon, that question became obsolete. The next question was far more ambitious. Could AI create images? The answer arrived with extraordinary speed. Systems such as Midjourney, alongside other image generation models developed across the industry, demonstrated that a simple sentence could become an astonishingly detailed illustration within seconds. A futuristic city at sunset, a medieval castle floating above the clouds, a portrait painted in Renaissance style. The machine transformed language into visual reality, not by copying a photograph, but by learning statistical patterns from enormous collections of images during training. Artists marveled, designers experimented, architects explored concepts, teachers created educational materials, filmmakers imagined new workflows. Creativity itself seemed to gain a new collaborator. Then another frontier fell. Video. Generating a convincing moving image had long been considered vastly more difficult than creating a single picture. A video must preserve consistency, lighting, motion, perspective, physics, expressions. Every frame influences the next. Yet, advances in generative AI began demonstrating that text could evolve into increasingly realistic moving scenes. Among the systems drawing widespread attention was Sora, illustrating how rapidly text-to-video technology was advancing. What once required teams of animators, visual effects artists, cameras, actors, and expensive production equipment could increasingly begin with a written prompt. The implications extended far beyond entertainment, advertising, education, scientific visualization, architecture, medicine, game development. Every industry involving visual communication suddenly faced profound transformation. But every powerful technology carries two possibilities: creation and deception. Imagine receiving a phone call late at night. A familiar voice speaks urgently. It sounds exactly like your daughter, or your father, or your closest friend. They say they have been arrested. They need money immediately. There is panic in their voice, fear, desperation. Everything sounds authentic, except the person is not actually speaking. Artificial intelligence generated the voice. Criminals needed only a brief audio sample collected from a social media video or public recording. Within minutes, software reproduced the tone, rhythm, accent, and emotional qualities of another human being. The scam feels intensely personal because it imitates trust itself. These incidents are no longer confined to science fiction. Authorities in multiple countries have warned about increasingly sophisticated voice cloning fraud targeting families and businesses. The technology continues improving rapidly. As synthetic voices become more natural, distinguishing between authentic and artificial speech grows more difficult. The consequences extend beyond financial crime. Trust itself begins to erode. Now imagine a different scenario. A video appears online showing a political leader announcing a shocking military action, or confessing to corruption, or insulting an allied nation. Millions watch before experts verify its authenticity. Financial markets react, diplomatic tensions rise, social media erupts. Hours later, investigators determine the video was fabricated. The damage, however, has already spread. Corrections rarely travel as quickly as sensational misinformation. This phenomenon lies at the heart of what many scholars describe as the post-truth era. The phrase does not mean truth has disappeared. It means objective facts increasingly compete with emotionally persuasive narratives. Artificial intelligence amplifies this challenge dramatically. Deepfake technology combines advanced image generation, voice synthesis, facial animation, and video editing into convincing simulations of reality. Modern systems can reproduce facial expressions, eye movements, lighting, speech patterns, and emotional nuance with startling realism. The human brain evolved to recognize faces extraordinarily well, yet it did not evolve to distinguish genuine faces from AI-generated ones. Our instincts become vulnerable. For centuries, the camera functioned as a witness. Now, the witness itself may be questioned. Ironically, the danger extends beyond convincing people that false events occurred. It also enables the opposite. Real evidence can now be dismissed as fake. Suppose an authentic recording reveals corruption, violence, or abuse. The individuals involved may simply claim it is AI generated. As deepfakes become increasingly sophisticated, such denials become more plausible to portions of the public. Researchers sometimes refer to this broader challenge as the liar's dividend. The existence of convincing synthetic media gives dishonest actors new opportunities to reject genuine evidence. Society, therefore, faces a double crisis. False material becomes more believable. True material becomes easier to question. Both outcomes weaken public trust, and trust is one of civilization's most valuable resources. Markets depend upon it, governments depend upon it, journalism depends upon it, science depends upon it, families depend upon it. Once trust begins eroding, rebuilding it becomes extraordinarily difficult. The scale of the challenge expands even further when combined with large language models. Imagine not one fabricated article, but 1 million, generated automatically within minutes, each written in a slightly different style, each targeting a different audience, each optimized for particular emotions: fear, anger, hope, patriotism, distrust. Algorithms can already produce vast quantities of persuasive text at remarkable speed. Combined with synthetic images, cloned voices, and generated videos, coordinated misinformation campaigns become dramatically easier to create than in previous decades. Social media platforms may face waves of AI-generated content that overwhelm traditional moderation systems. Researchers, governments, and technology companies have increasingly studied how generative AI could influence public discourse, particularly during elections and major geopolitical events. The concern is not simply that AI can create false stories. Humans have always invented rumors. The concern is scale. Automation changes everything. A handful of individuals may now generate content volumes that once required entire organizations. Speed compounds the challenge. False information may circle the globe before investigators complete verification. Emotion often spreads faster than careful analysis. This is not a weakness unique to the internet. It reflects fundamental aspects of human psychology. People naturally share surprising stories. Outrage attracts attention. Certainty often feels more satisfying than nuance. Artificial intelligence can amplify each of these tendencies. Does this mean democracy itself is doomed? Not necessarily. History suggests that societies eventually develop defenses against new forms of deception. Printing presses enabled propaganda. Journalism evolved. Photography enabled manipulation. Forensic analysis improved. Cybercrime increased. Digital security advanced. Every communication revolution creates new risks. Human institutions gradually adapt. The same process is unfolding today. Researchers develop systems capable of detecting synthetic media. Technology companies explore methods for identifying AI-generated content. Some organizations investigate cryptographic techniques for verifying authentic photographs and videos from the moment they are captured. Newsrooms strengthen verification procedures. Governments debate legal frameworks addressing deceptive AI use while attempting to preserve legitimate creative and educational applications. None of these solutions is perfect, but neither are they static. The contest between generation and detection resembles an endless race. Each improvement in synthetic media inspires improvements in verification. Each defensive innovation encourages more sophisticated deception. The balance continues shifting. This chapter is not a prediction that artificial intelligence will inevitably destroy truth, nor is it an argument against technological progress. Generative AI also enables extraordinary benefits. Filmmakers can create scenes once impossible to afford. Teachers can build immersive educational experiences. Museums can reconstruct ancient civilizations. Doctors can visualize complex medical concepts. Scientists can simulate environments that would otherwise remain inaccessible. Artists gain entirely new creative tools. Innovation and risk arrive together, as they often do. The true challenge lies not in the technology itself, but in the wisdom with which societies choose to use it. Perhaps the greatest transformation of the AI era is not that machines can now generate convincing words, images, voices, and videos. It is that humanity must rethink how it defines evidence. Future generations may no longer ask, "Did you see it?" Instead, they may ask, "Can it be verified?" The difference appears subtle. Its consequences are profound. Civilization has long depended upon shared reality, shared facts, shared records, shared trust. Artificial intelligence is forcing us to rebuild those foundations for a world where reality itself can be manufactured with astonishing precision. The valley of truth has not disappeared, but it has become surrounded by reflections, some genuine, some artificial, some impossible to distinguish at first glance. Navigating that landscape may become one of the defining skills of the 21st century, because in the age of generative intelligence, our greatest challenge may no longer be creating information. It may be recognizing which information still deserves to be believed. Chapter 7: The Pursuers Behind, the Three-Way Race and the Battle of Continents. For much of the world's attention, the artificial intelligence revolution appeared to be a contest between two familiar names: OpenAI, Google. One captured the public imagination. The other defended a technological empire built over 2 decades. The headlines often frame the story as a duel, but history rarely unfolds as a duel. It unfolds as a race, and races attract more competitors than anyone expects. While Silicon Valley dominated international headlines, another technology ecosystem was moving rapidly in parallel. Across the Pacific, China's largest technology companies had been investing in artificial intelligence for years. Long before ChatGPT became famous, Chinese researchers were publishing influential scientific papers, building powerful machine learning systems, and competing at the highest levels of AI research. The difference was not capability. The difference was visibility. When the global AI race accelerated, the world suddenly realized that it was not watching one competition. It was watching several, unfolding simultaneously, and each was shaped by different priorities, different markets, and different political systems. Among China's technology leaders, one company faced a challenge strikingly similar to Google's: Baidu. For years, Baidu had been China's dominant search engine, serving hundreds of millions of users and occupying a position within its domestic market that invited comparisons with Google elsewhere. Like Google, Baidu had invested heavily in artificial intelligence research. Like Google, it understood that conversational AI might fundamentally change how people searched for information. And like Google, it needed an answer. That answer became Ernie Bot. Built upon Baidu's large language model research, Ernie represented the company's effort to compete in the rapidly evolving era of generative AI. The launch signaled something important. China's technology industry was not standing still. It intended to participate actively in the next generation of artificial intelligence. But Baidu was not alone. Alibaba, through its cloud computing and AI initiatives, accelerated development of increasingly capable foundation models intended for businesses, developers, and enterprise customers. Tencent, already deeply integrated into the daily digital lives of hundreds of millions of users through messaging, gaming, and online services, expanded its own AI capabilities across multiple products. Other Chinese firms, universities, and research institutions also intensified their efforts. The result was not a single national AI project. It was a broad ecosystem of competing organizations pursuing different strategies while sharing a common recognition. Artificial intelligence would become one of the defining technologies of the century. No major technology company could afford to remain on the sidelines. At first glance, the competition between American and Chinese AI companies appears remarkably similar. Both train increasingly capable language models. Both invest enormous sums in computing infrastructure. Both recruit world-class researchers. Both race to improve reasoning, programming, multimodal understanding, and scientific capabilities. Yet beneath these similarities lies a profound difference. The informational environments in which these systems operate are not identical. Every AI reflects the conditions under which it is developed, its language, its training data, its objectives, its legal obligations, its cultural assumptions, and perhaps most importantly, the regulatory framework governing its deployment. Here, the paths begin to diverge. Developing advanced artificial intelligence is already one of the most difficult engineering challenges humanity has ever attempted. Building a system that is helpful, reliable, and safe requires enormous effort. Now imagine adding another requirement. The system must also operate within a comprehensive framework governing online information. This has been one of the distinctive challenges facing AI development in China. Chinese technology companies operate under regulations that include requirements related to content governance, security, and the management of certain categories of public information. As a result, developers must design systems capable not only of producing useful answers, but also of complying with applicable legal and regulatory standards. From an engineering perspective, this introduces an additional layer of complexity. The model must generate fluent language, avoid harmful outputs, reduce misinformation, respect legal requirements, and remain useful to users. Balancing these objectives is technically demanding under any regulatory environment. Different countries approach these questions differently. Some emphasize freedom of expression. Others place greater emphasis on social stability, public order, or national security. Artificial intelligence inevitably reflects those choices. Engineers therefore confront questions extending far beyond computer science. Where should the boundaries of an AI's responses be drawn? Who decides? Governments? Private companies? Independent regulators? International organizations? There are no universally accepted answers. Every society continues negotiating these questions in real time. Interestingly, these challenges are not unique to China. Technology companies throughout the world face increasing pressure regarding AI governance. In Europe, lawmakers focus heavily on privacy, transparency, and risk management. In the United States, debates continue over safety, competition, copyright, and liability. Many other countries are developing their own regulatory frameworks as generative AI becomes more widely adopted. The difference often lies in emphasis rather than existence. No advanced AI system operates entirely outside governance. Every major developer must navigate an evolving landscape of laws, public expectations, and ethical concerns. The age of unrestricted experimentation is gradually giving way to the age of regulated intelligence. Yet perhaps the most fascinating question concerns the future of the internet itself. For nearly 3 decades, despite national differences, the internet often appeared to function as a broadly interconnected global network. People searched similar websites, shared scientific papers, read international news, watched the same viral videos, communicated across borders with unprecedented ease. Artificial intelligence introduces the possibility of a different future. Instead of everyone accessing similar information through search engines, billions of people may increasingly rely on AI assistants. Those assistants do not merely retrieve information, they interpret it, summarize it, prioritize it, sometimes even decide which sources deserve attention. In other words, AI becomes an intermediary between humans and knowledge. Now imagine that different regions rely primarily on different AI ecosystems. One set of models dominates much of North America and Europe. Another becomes widely adopted across China. Other regions develop additional systems reflecting local languages, values, and regulatory priorities. The internet remains connected physically, yet people's informational experiences gradually diverge. Two individuals asking identical questions might receive noticeably different answers depending on which AI they consult. Not necessarily because one system is technically superior, but because different systems optimize for different objectives, data sources, and governance frameworks. This possibility has prompted scholars to discuss whether artificial intelligence could contribute to a more fragmented digital landscape. Some describe this broader trend as the emergence of distinct technological ecosystems rather than a single universal experience. Whether such fragmentation deepens or diminishes remains uncertain, but the question itself is becoming increasingly important. History offers useful perspective. The world has long operated with multiple legal systems, multiple languages, multiple educational traditions, multiple media environments. Artificial intelligence may simply reflect those existing differences rather than create entirely new ones. On the other hand, AI assistants could become so influential that they shape how future generations understand science, history, economics, politics, and culture. If that occurs, differences between AI ecosystems may have profound long-term consequences. Knowledge is never entirely neutral. The selection of examples matters. The framing of explanations matters. The omission of details matters. Every educational system makes choices. Every encyclopedia makes editorial decisions. Every search engine ranks results according to particular algorithms. Artificial intelligence inherits these complexities while adding a conversational interface that often feels deeply authoritative. That combination increases both its usefulness and its responsibility. Despite growing geopolitical competition, it is important to remember another reality. Scientific progress has always crossed borders. Researchers read one another's papers. Engineers learn from international conferences. Universities educate students from many nations. Open source software communities include contributors across continents. Competition and collaboration frequently coexist. The AI revolution reflects both dynamics simultaneously. Companies compete fiercely for commercial leadership. Researchers continue exchanging ideas through scientific publications. Governments invest strategically. International organizations discuss standards. No single narrative fully captures this complexity. The race is global, but it is not purely adversarial. It is also deeply interconnected. Perhaps the future will not belong to one civilization's artificial intelligence. Perhaps it will belong to many. Some optimized for scientific discovery, some specialized in medicine, some built for education, some designed for enterprise, some reflecting different languages, legal traditions, and cultural contexts. The challenge will not merely be building more powerful AI. It will be ensuring that different systems can coexist without deepening misunderstanding between societies. Because technology alone cannot determine the future. Human choices will, policies will, institutions will, trust will. The artificial intelligence race is therefore larger than a contest among companies. It is a contest among models of innovation, among regulatory philosophies, among visions of how intelligent machines should serve humanity. Silicon Valley represents one path. China represents another major center of development. Other regions continue expanding their own capabilities. The map of artificial intelligence is becoming increasingly multipolar, and the competition has only begun. The next decade may not determine which chatbot answers questions more elegantly. It may determine something far more consequential. Whether artificial intelligence becomes a bridge connecting civilizations or another force encouraging the world to divide into separate technological spheres. The answer has not yet been written. It is being shaped every day in research laboratories, government offices, data centers, universities, and boardrooms across continents. The future of AI will not belong to one nation alone. It will emerge from a global race whose outcome will influence how billions of people learn, communicate, create, and understand the world around them for generations to come. Chapter 8: The OpenAI Upheaval, the Struggle Between Profit and Safety. Every revolution eventually reaches a moment when its greatest conflict is no longer between rivals, but within itself. The history of artificial intelligence is often told as a competition between companies: OpenAI against Google, Microsoft against Amazon, the United States against China. Yet one of the most dramatic chapters in the AI race unfolded inside a single organization. There were no hackers, no hostile takeover, no external attack. Instead, the conflict came from the very people responsible for guiding one of the world's most influential AI laboratories. For a few extraordinary days in late 2023, the future of OpenAI seemed uncertain. Its chief executive was gone. Its employees were in open revolt. Its largest commercial partner faced an impossible decision, and the entire technology industry watched in disbelief. The event became one of Silicon Valley's most remarkable corporate dramas. Not because it involved financial collapse, but because it revealed a deeper question that continues to shape artificial intelligence today. What matters more, moving fast or moving safely? To understand why the crisis erupted, we must remember that OpenAI was never an ordinary startup. Unlike many technology companies, OpenAI was founded with an unusual mission. Its original purpose was not simply to build powerful AI, it was to ensure that increasingly capable artificial intelligence would benefit humanity. This mission influenced the organization's governance. OpenAI's nonprofit board was designed to consider long-term safety alongside technological progress. In theory, this structure offered something rare in Silicon Valley, a mechanism intended to prevent commercial incentives from becoming the only force guiding development. It was an ambitious experiment, but experiments become difficult when success arrives faster than expected. By 2023, OpenAI had become one of the most influential companies in the world. ChatGPT had reached hundreds of millions of users. Developers were building businesses on OpenAI's models. Governments sought meetings. Researchers accelerated their work. Competitors raced to catch up. Investment surged. Every breakthrough increased both opportunity and pressure. The organization that had once worried about hypothetical future risks now stood at the center of a global technological revolution, and revolutions rarely leave ideals unchanged. At the center of this story stood Sam Altman, calm, deliberate, and remarkably focused on long-term technological transformation. Altman had become the public face of OpenAI. He spoke not only about chatbots, he spoke about scientific discovery, medical advances, economic productivity, artificial general intelligence, the possibility that machines might someday perform many intellectual tasks at or beyond human capability. To supporters, Altman represented visionary leadership, someone capable of transforming ambitious research into technology that reached billions of people. He attracted investment, inspired developers, built partnerships, expanded OpenAI from a respected research laboratory into one of the world's most important technology organizations. Yet rapid growth inevitably creates tension. The faster an organization moves, the more difficult governance becomes. Another central figure in this story was Ilya Sutskever, a brilliant researcher and one of the leading scientists in modern deep learning. Sutskever helped shape many of the technical foundations upon which OpenAI was built. His reputation within artificial intelligence extended far beyond any single company. For years, he had spoken thoughtfully about the extraordinary potential of advanced AI. But he had also expressed concern about its long-term risks. As AI systems became increasingly capable, questions surrounding alignment and safety grew more urgent. How can humanity ensure that future AI systems remain beneficial? How can increasingly autonomous systems behave according to human intentions? How should researchers respond if AI capabilities advance faster than society's ability to govern them? These questions are sometimes described collectively as the problem of AI alignment. Unlike engineering challenges involving speed or accuracy, alignment concerns values, objectives, and long-term consequences. Many researchers consider it one of the most important scientific problems of the century. Within OpenAI, different perspectives naturally emerged regarding how quickly increasingly capable systems should be developed and deployed. Some emphasized rapid innovation and learning through real-world use. Others argued that greater caution was necessary as capabilities accelerated. Both perspectives reflected genuine concerns. Innovation creates opportunity. Safety reduces risk. Balancing the two is extraordinarily difficult. Then came November 2023. Without warning to the broader public, OpenAI's board announced that Sam Altman would no longer serve as chief executive. The statement surprised nearly everyone. Employees, investors, business partners, governments, technology journalists, even many individuals closely following artificial intelligence struggled to understand what had happened. The announcement referenced concerns regarding communication between Altman and the board, but provided few public details. Speculation spread immediately. Had disagreements over governance reached a breaking point? Were there disputes regarding commercial strategy? Did differing views about AI safety contribute? The precise combination of factors remains the subject of continuing discussion. What became undeniable, however, was the scale of the reaction. Instead of stabilizing the organization, the dismissal triggered a crisis. The response inside OpenAI was extraordinary. Hundreds of employees signed a public letter calling for changes in the company's leadership structure and expressing support for Altman's return. The message carried unusual weight. Many of the world's leading AI researchers worked at OpenAI. If they departed together, the organization risked losing not merely employees, but much of its intellectual foundation. Talent has always been valuable in technology. In artificial intelligence, may be the most valuable resource of all. Researchers cannot simply be replaced like office equipment. Years of expertise, collaboration, institutional knowledge, scientific intuition, these qualities accumulate slowly. Losing them can alter the future of an organization. The possibility that a large portion of OpenAI's workforce might resign transformed an internal governance dispute into an existential crisis. Meanwhile, another major actor entered the story: Microsoft. By late 2023, Microsoft had invested billions of dollars in OpenAI and integrated its technology across numerous products and services. The partnership had become central to Microsoft's AI strategy. Instability at OpenAI therefore carried significant implications. Microsoft CEO Satya Nadella responded quickly. He announced that Sam Altman and key colleagues would have opportunities to continue their work at Microsoft if circumstances required. The announcement sent a powerful signal. OpenAI's leadership dispute was no longer an isolated corporate matter. It now affected one of the world's largest technology companies. Observers watched events unfold almost hour by hour. Would OpenAI survive? Would its researchers leave? Would Microsoft effectively absorb much of the organization's talent? Would the AI race suddenly change direction? For several days, almost anything seemed possible. Then came one of the most dramatic reversals in recent corporate history. Sam Altman returned. OpenAI's governance evolved. Several board members departed. The immediate crisis subsided. The company resumed its work. To outside observers, the sequence appeared astonishing. A chief executive removed, employees threatening to leave, a strategic partner preparing alternatives, then a rapid restoration. Yet beneath the headlines lay deeper questions that remain unresolved. What should happen when commercial success accelerates faster than governance structures? Can organizations dedicated to AI safety maintain independence while competing in markets requiring enormous investment? Who should ultimately decide how rapidly frontier AI systems are deployed? Scientists, executives, boards, governments, international institutions? These questions extend far beyond OpenAI. They concern every organization developing increasingly capable artificial intelligence. Some commentators interpreted the events as evidence that commercial momentum had become too powerful to resist. Others argued the episode demonstrated that governance mechanisms, however imperfect, were functioning by forcing difficult conversations into public view. Reality is likely more complex. Large organizations rarely operate according to simple narratives. Individuals often share the same ultimate goal while disagreeing profoundly about the best path toward achieving it. One researcher may believe rapid deployment improves safety by exposing weaknesses earlier. Another may believe slower development reduces systemic risk. Neither position necessarily reflects bad faith. Both arise from different assessments of uncertainty. The challenge is that uncertainty itself cannot be measured with precision. No one knows exactly how quickly AI capabilities will advance over the coming decades. No one knows exactly when or whether systems approaching artificial general intelligence will emerge. Decision makers therefore operate under profound uncertainty. History offers few comparable situations. The OpenAI crisis also revealed something fundamental about power in the AI era. Money alone cannot build frontier artificial intelligence, but neither can ideals alone. Researchers require extraordinary computational resources. Computational resources require enormous investment. Investment creates commercial expectations. Commercial expectations influence organizational decisions. The relationship is circular. Technology depends upon capital. Capital depends upon technological progress. Governance attempts to balance both. Maintaining that balance may become increasingly difficult as AI grows more capable and more economically valuable. Perhaps the most enduring lesson of the OpenAI upheaval is not that one side won while another lost. The deeper lesson is that artificial intelligence has entered a stage where technical questions can no longer be separated from ethical, organizational, and societal ones. The algorithms may be mathematical. The decisions surrounding them are profoundly human. They involve judgment, responsibility, trust, competing visions of the future. The conflict between speed and safety did not end when Sam Altman returned. It continues today across laboratories, boardrooms, universities, governments, and international organizations around the world. Every new model, every new capability, every new breakthrough reopens the same debate. How fast is too fast? How much caution is enough? And who gets to decide? The extraordinary events of late 2023 offered no final answers, but they revealed something essential. The greatest struggle in artificial intelligence may never be between humans and machines. It may be between different human visions of how those machines should shape civilization. The future of AI will depend not only on what we are capable of building, but also on the wisdom with which we choose to guide it. Chapter 9, The Alarm Bell for the Labor Market. AI is not coming to replace you, but someone who uses AI might. Every industrial revolution begins with the same promise. Machines will make life easier. They will eliminate repetitive work, increase productivity, reduce costs, create new opportunities. History shows that these promises are often true, but history also teaches another lesson. Every technological revolution changes the value of human skills. The steam engine transformed agriculture, electricity reshaped manufacturing, the internet reinvented communication. Artificial intelligence is beginning to redefine knowledge work. For generations, people believed that manual labor would be automated first. Factories, warehouses, assembly lines, heavy machinery. The common assumption was simple. The safer your career was from physical automation, the more secure your future would be. Then came generative AI, and suddenly, the first professions feeling its impact were not factory workers. They were programmers, writers, designers, lawyers, consultants, translators, teachers, marketing specialists, financial analysts, people whose primary tool was not a hammer, but knowledge. The revolution had arrived through the office door. Perhaps the greatest misunderstanding surrounding artificial intelligence is the belief that it will simply replace entire professions overnight. Reality is usually more complicated. Technology rarely removes jobs in one dramatic moment. Instead, it changes workflows, it changes expectations, it changes productivity, and eventually, it changes hiring. Consider software development. Only a few years ago, writing thousands of lines of computer code required teams of programmers working together for weeks. Today, AI coding assistants can generate boilerplate functions, explain unfamiliar programming languages, identify bugs, suggest improvements, and accelerate testing. Experienced developers increasingly describe these systems as powerful collaborators. For routine tasks, productivity has risen significantly. But this creates an unexpected consequence. If one highly skilled programmer equipped with AI can accomplish work that previously required several people, how many programmers does a company need? The question is uncomfortable. Yet businesses ask uncomfortable questions every day. The same pattern appears elsewhere. Graphic designers use AI to generate concept art in seconds. Marketing teams produce campaign ideas almost instantly. Translators accelerate multilingual communication with AI-assisted workflows. Customer support organizations deploy increasingly capable conversational systems that resolve many routine inquiries before a human representative becomes involved. Content creators brainstorm articles, advertisements, scripts, and presentations with intelligent assistants. Artificial intelligence does not perform every task perfectly, but it often performs enough of the task to change economics, and economics influences employment. It is important, however, to distinguish between automation and elimination. Many headlines suggest AI is taking jobs. The reality varies widely across industries. Some organizations have reduced hiring for certain routine tasks. Others have restructured teams around AI-assisted workflows. Still others have created entirely new roles focused on supervising, integrating, evaluating, or improving AI systems. History suggests that technological progress often eliminates particular tasks faster than it eliminates entire professions. Accountants still exist despite spreadsheets. Travel agents did not disappear entirely after online booking. Doctors remain essential despite extraordinary advances in medical imaging. Instead, professionals adapt. Their highest value work changes. Artificial intelligence appears to be following a similar pattern. Routine work becomes increasingly automated. Judgment, creativity, interpersonal communication, leadership, and domain expertise become relatively more valuable. The challenge is that transitions are rarely comfortable. Workers must adapt while the rules continue changing. Imagine an advertising agency in the early 2020s. Five specialists collaborate on a campaign. One writes copy, another creates illustrations, a third edits images, a fourth researches competitors, a fifth prepares presentations for clients. Now imagine the same agency only a few years later. The team still requires creative direction. It still needs strategic thinking. It still depends upon human relationships with clients. But many supporting tasks happen dramatically faster. AI drafts initial copy, generates multiple visual concepts, summarizes market research, suggests presentation layouts, translates materials into several languages. One experienced professional equipped with sophisticated AI tools may now complete portions of work that previously required several specialists coordinating together. This does not mean 4 people inevitably lose their jobs. It does mean organizations may reconsider how many people they hire, how quickly projects move, and which skills command the greatest value. Productivity changes incentives. Incentives reshape labor markets. The transformation is gradual, yet powerful. A similar evolution is unfolding in customer service. For decades, businesses expanded call centers by hiring increasing numbers of representatives. Many customer questions followed familiar patterns: password resets, shipping updates, billing inquiries, appointment scheduling. Today, conversational AI systems increasingly handle large volumes of these routine interactions. Human representatives remain essential for complex situations requiring empathy, negotiation, or nuanced judgment. But routine interactions often become automated first. This pattern repeats across industries. Artificial intelligence does not eliminate the most difficult work. It frequently eliminates the most repetitive work. And repetitive work has historically employed millions of people. The emotional consequences may prove as significant as the economic ones. Throughout history, workers generally feared being replaced by younger employees, or by overseas competition, or by economic recession. Now, many knowledge workers face a different anxiety: being replaced by software, or more precisely, being replaced by someone who knows how to use that software more effectively. Consider 2 architects. Both possess similar education, similar experience, similar creativity. One embraces AI-assisted design, rapidly exploring dozens of concepts before selecting the strongest solution. The other relies exclusively on traditional methods. After several years, which architect completes projects faster? Which responds to clients more quickly? Which experiments with more possibilities? The answer illustrates an important distinction. Artificial intelligence often acts as a force multiplier. It amplifies existing capabilities. Those who integrate it effectively may gain significant advantages. Those who ignore it may struggle to remain competitive. This dynamic extends far beyond architecture. Medicine, finance, engineering, journalism, education, scientific research, law. Nearly every knowledge-intensive profession is beginning to experience similar pressures. Psychologists increasingly recognize another dimension of this transition: uncertainty. Unlike previous technological changes that unfolded over decades, generative AI has advanced with extraordinary speed. Many professionals wake each morning wondering whether a newly released model can perform another part of their work. That uncertainty affects confidence, career planning, education, identity. For many people, occupation is more than income. It is purpose, status, self-worth. When technology begins performing tasks once considered uniquely human, individuals naturally ask difficult questions. What remains uniquely mine? Which skills should I develop? Will my experience still matter 5 years from now? These concerns are not irrational. They reflect genuine uncertainty during a period of rapid technological change. Yet uncertainty should not be confused with inevitability. History repeatedly demonstrates that humans adapt. The professions of tomorrow rarely look exactly like the professions of yesterday. Education therefore faces one of its greatest transformations in generations. For decades, schools emphasized memorization, standardized procedures, individual production of assignments. Artificial intelligence challenges each of these assumptions. If AI can instantly draft essays, summarize textbooks, solve programming exercises, generate illustrations, and explain mathematics, then what should education emphasize? Perhaps critical thinking, perhaps evaluation rather than memorization, perhaps asking better questions rather than producing faster answers, perhaps collaboration between humans and intelligent tools. The workforce of the future may not compete against AI, it may compete through AI. That distinction changes everything. The phrase often repeated in discussions about artificial intelligence is intentionally provocative. AI will not replace you. A person using AI will. Like many memorable slogans, it captures part of the truth while oversimplifying a much more complex reality. Artificial intelligence alone does not automatically outperform experienced professionals. Expertise still matters. Judgment still matters. Ethics still matter. Communication still matters. But professionals who combine those strengths with effective AI use may achieve dramatically higher productivity. The competitive advantage therefore shifts, not toward machines alone, nor toward humans alone, but toward collaboration. The most valuable worker may increasingly become the one who knows when to trust AI, when to question it, when to verify it, and when to ignore it entirely. There is another lesson hidden beneath this transformation. Every technological revolution rewards learning. Those willing to acquire new skills often discover opportunities invisible to others. The arrival of electricity created electricians. The internet created web developers. Smartphones created app designers. Artificial intelligence is already generating entirely new professions. Prompt engineers, AI safety specialists, model evaluators, synthetic media experts, AI governance consultants, machine learning operations engineers, human AI interaction designers. Many occupations that will define the next decade may not yet have widely recognized names. This has always been true of technological change. The future rarely eliminates work altogether. It redistributes it. The greatest challenge of the AI era may therefore be psychological rather than technological. Fear encourages paralysis. Curiosity encourages adaptation. No one can guarantee exactly how labor markets will evolve over the next 20 years. Some professions will change dramatically, others more gradually. Some entirely new industries will emerge, others will decline. What remains constant is humanity's remarkable capacity to learn. Artificial intelligence is not simply forcing workers to compete with machines. It is inviting workers to redefine what uniquely human value means in an age of intelligent software. The office of the future may look familiar. People will still meet, discuss ideas, solve problems, lead teams, build relationships. But beside every professional may stand an increasingly capable digital collaborator. The question will no longer be whether AI exists. That question has already been answered. The real question is whether individuals choose to understand it, master it, and shape it, or allow someone else to do so first. Because in every technological revolution, the greatest risk is rarely the machine itself. It is standing still while the world quietly learns to move faster. Nagara, Chapter 10, Cracks in Copyright, the Endless Legal War over Artificial Intelligence. Every technological revolution eventually reaches a courtroom. The printing press challenged the control of knowledge. Photography transformed ideas of ownership. Radio changed the economics of music. The internet forced governments to rethink copyright in the digital age. Artificial intelligence is now creating the next great legal confrontation. But unlike previous disputes, this one asks a question that reaches into the very foundations of creativity. Can a machine learn from humanity's collective knowledge without violating the rights of the humans who created it? The answer may determine not only the future of AI, but also the future of journalism, literature, science, education, and every profession built upon original thought. Because before an AI can write, it must first learn. And before it can learn, someone must decide what it is allowed to study. When people interact with a conversational AI, the process appears almost magical. A question is typed, a thoughtful answer appears. Behind that simple interaction lies an enormous training process involving vast collections of text from publicly available sources, licensed material, and other datasets assembled under different legal and contractual arrangements. The scale is almost impossible to imagine. Billions of words, millions of documents, books, scientific papers, programming code, reference materials, public websites, news articles, discussion forums, educational content. Human civilization has spent centuries recording its knowledge. Modern AI systems learn statistical patterns from portions of that recorded knowledge. For years, this process remained largely invisible to the public. Then the lawsuits began. Among the most significant legal challenges emerged at the end of 2023. The New York Times, one of the world's most influential newspapers, filed a lawsuit against OpenAI and Microsoft. The newspaper argued that its copyrighted journalism had been used in ways that infringed its rights and that AI systems could generate outputs closely resembling or drawing upon its reporting in certain circumstances. The case immediately attracted worldwide attention, not simply because it involved famous organizations, but because it represented a broader conflict affecting the entire creative economy. Journalism is expensive. Investigative reporting requires reporters, editors, photographers, foreign correspondents, fact checkers, legal review, months of research, sometimes years. The resulting articles become part of society's shared understanding of events. If artificial intelligence systems learn from those articles without licensing arrangements acceptable to the publishers, what happens to the economic foundation supporting professional journalism? That question extends far beyond one newspaper. It concerns every organization investing resources to produce original knowledge. The lawsuit therefore became symbolic. It represented an industry asking whether existing copyright law remains sufficient in the age of generative AI. Supporters of AI research often present a different perspective. Human beings also learn by reading. Students study textbooks. Scientists build upon previous discoveries. Writers read novels before writing their own. Artists visit museums. Musicians listen to earlier generations. Knowledge has always evolved through learning from what came before. From this viewpoint, training an AI resembles education rather than duplication. The machine identifies patterns, relationships, structures. It does not simply store entire libraries for later retrieval. Critics respond that the comparison has limits. A human reader cannot instantly absorb billions of documents. A human author cannot reproduce stylistic patterns across millions of works within seconds. Artificial intelligence operates at a scale no individual can match. Scale changes consequences. What may appear reasonable for a single student becomes far more complicated when performed by machines processing extraordinary quantities of copyrighted material. This tension lies at the center of the legal debate. Where exactly does learning end and infringement begin? No universal answer yet exists. The concerns extend well beyond journalism. Across creative industries, artists, musicians, photographers, writers, illustrators, actors, and researchers have expressed worries about how their work contributes to AI training. Many ask a straightforward question. If my work helped create valuable AI systems, should I receive compensation? It is an understandable concern. Imagine spending decades developing a distinctive artistic style, publishing best-selling novels, composing music, producing scientific research, building educational materials, then discovering that sophisticated AI systems may have learned statistical patterns from works like yours during training. Some creators feel honored that their contributions influence technological progress. Others feel their intellectual labor has been incorporated into commercial products without meaningful permission or compensation. The debate therefore concerns more than law. It concerns fairness, recognition, economic value, respect for creative labor. One phrase frequently appears in these discussions. AI is copying human intelligence, or more colloquially, it is memorizing by imitation. The reality is more nuanced. Large language models generally do not function as enormous databases storing exact copies of everything they encounter. Instead, they learn mathematical relationships between words, concepts, structures, and patterns. Most outputs are newly generated rather than retrieved verbatim. Yet important exceptions exist. Researchers have demonstrated that under certain conditions, language models may reproduce portions of memorized training material, particularly when prompted in specific ways or when dealing with frequently repeated content. Developers actively work to reduce such behavior. Nevertheless, the possibility raises legitimate legal and technical questions. How much similarity is acceptable? What constitutes transformation? When does statistical learning become unauthorized reproduction? These questions challenge legal systems originally designed for human creators rather than machine learning algorithms. Scientists face related concerns. Research papers represent years of experimentation. Medical discoveries require extensive funding. Peer review demands expertise. Universities and research institutions invest enormous resources generating reliable knowledge. If AI systems summarize that knowledge effectively, society benefits through wider access. But if the economic incentives supporting original research weaken, future scientific progress could suffer. The same tension appears across nearly every knowledge-intensive field. Creative works fuel AI. AI increases access to creative works. Who should receive the resulting value? The answer influences the future incentives for creation itself. Economics and ethics become inseparable. History reminds us that copyright law has always evolved alongside technology. The printing press forced societies to define literary ownership. Photography required new legal protections for visual works. Recorded music transformed performance rights. Digital media introduced licensing systems for online distribution. Streaming services reshaped the economics of entertainment. Each technological leap initially produced uncertainty, then negotiations, then legislation, then new business models. Artificial intelligence appears to be following the same historical pattern. The law often moves more slowly than innovation. Engineers release new capabilities within months. Courts may require years to resolve disputes. Legislatures sometimes need even longer to establish comprehensive regulatory frameworks. During that interval, uncertainty dominates. Rather than waiting for litigation alone, many organizations have begun exploring alternative approaches. Some publishers negotiate licensing agreements with AI companies. Certain media organizations have entered partnerships allowing authorized access to archives under commercial terms. Stock image providers have developed licensing arrangements for AI training or created their own generative tools using content contributed under specific agreements. Some authors choose to license their works, others opt out where mechanisms exist. The landscape continues evolving rapidly. Instead of one universal solution, multiple models may emerge. Licensing, revenue sharing, collective rights management, technical restrictions, transparency requirements. Each attempts to balance innovation with compensation. The broader philosophical question remains deeply challenging. Knowledge has always been cumulative. Isaac Newton famously wrote of standing on the shoulders of giants. Every scientist builds upon previous discoveries. Every composer inherits musical traditions. Every language itself reflects thousands of years of shared human development. Artificial intelligence extends this cumulative process to unprecedented scale. The challenge is ensuring that scale does not undermine the incentives that encourage future creativity. If creators conclude their work will simply become free raw material for commercial AI systems without meaningful recognition or compensation, some fear investment in original creation could decline. Others argue the opposite. They believe AI will expand demand for high-quality human work by increasing productivity and creating new markets. History provides evidence supporting both optimism and caution. Another emerging challenge involves attribution. Suppose an AI generates a painting strongly resembling the style of a famous artist. Who owns it? The user? The software company? No one? What if the resemblance becomes so close that viewers mistake it for the artist's own work? Or imagine a language model producing prose remarkably similar to a living author's distinctive voice. Should style itself receive legal protection? Most copyright systems traditionally protect specific expressions rather than artistic styles or general ideas. Generative AI blurs those distinctions. Machines can imitate characteristics without reproducing identical text. Existing legal categories become increasingly difficult to apply. Perhaps the greatest irony is that artificial intelligence itself may eventually help solve some of these problems. Future systems could identify copyrighted material more accurately, track licensing automatically, verify content provenance, distribute royalties through increasingly sophisticated digital infrastructures. Technology that complicates copyright may also strengthen it. Innovation often creates both the problem and part of the solution. The legal battle surrounding artificial intelligence is therefore not merely about lawsuits. It is about defining the rules for a new relationship between human creativity and machine intelligence. Society must answer difficult questions. How should creators be compensated? How transparent should AI training be? Which uses qualify as legitimate learning? Which require permission? How can innovation continue without weakening the people whose work makes innovation possible? These questions cannot be answered by engineers alone, nor by courts alone. They require cooperation among lawmakers, creators, technology companies, educators, researchers, and the public. The courtroom may seem far removed from laboratories filled with advanced computers. Yet the future of artificial intelligence may depend as much upon judges and legislators as upon scientists. Because intelligence is not merely a technical achievement, it is also a social contract, one that determines how knowledge is shared, how creativity is rewarded, and how civilization balances progress with fairness. The legal war has only begun. Its outcome will shape the creative economy for generations, not by deciding whether artificial intelligence should exist. That question has already been answered, but by determining whether humanity can build increasingly intelligent machines while preserving the dignity, rights, and livelihoods of the humans whose ideas made those machines possible in the first place. Chapter 11, The Frontier of Artificial General Intelligence, The Day the Machines Awaken. Throughout history, humanity has measured intelligence in many ways: the ability to calculate, to remember, to reason, to invent, to communicate, to solve problems. For centuries, one assumption remained unchallenged: no machine could equal the flexible intelligence of the human mind. A calculator could perform arithmetic faster than any mathematician. A chess computer could defeat world champions. A search engine could retrieve information in milliseconds. But each system excelled only within narrow boundaries. Outside its specialized task, it knew nothing. Artificial intelligence changed that picture. Modern AI systems can write essays, generate software, translate languages, analyze images, summarize scientific papers, compose music, assist physicians, tutor students, and converse naturally across thousands of subjects. Yet, despite these remarkable achievements, today's most advanced systems remain examples of what researchers generally call narrow AI. They are extraordinarily capable, but they are not truly general. They still depend on human-designed objectives, specialized training, and important practical limitations. Beyond this stage lies a concept that has fascinated scientists, philosophers, engineers, and science fiction writers for generations: artificial general intelligence, or simply, what exactly is AGI? The definition varies among researchers, but the central idea remains remarkably consistent. An artificial general intelligence would possess the ability to learn, reason, adapt, and solve problems across an extremely broad range of domains, rather than being limited to one specialized task. Instead of mastering chess alone, or language alone, or mathematics alone, an AGI could potentially perform many intellectual tasks at a level comparable to, or perhaps exceeding, that of highly capable humans. Imagine a single system capable of conducting scientific research in the morning, designing spacecraft in the afternoon, negotiating international agreements in the evening, and discovering new medical treatments overnight. It could learn unfamiliar disciplines rapidly, transfer knowledge between different fields, develop entirely new strategies without explicit programming. Such a system would represent more than another software application. It would mark a fundamentally new stage in the history of intelligence. For the first time on Earth, humanity might no longer be the only species capable of broadly applicable high-level reasoning. Whether AGI will emerge in years, decades, or much longer remains deeply uncertain. Leading researchers disagree substantially about timelines. Some believe current approaches may eventually scale toward increasingly general capabilities. Others argue that significant conceptual breakthroughs are still required. No one knows, and uncertainty itself shapes the debate. Throughout history, technological progress has generally amplified human abilities. The wheel amplified movement, the telescope amplified vision, the computer amplified calculation. AGI, if achieved, would amplify intelligence itself. This possibility inspires extraordinary optimism. An AGI might help discover cures for diseases that have resisted medicine for centuries. It could accelerate clean energy research, model climate systems with unprecedented precision, design safer materials, optimize agriculture, expand scientific understanding at a pace impossible for human researchers alone. Problems requiring generations of work might be approached in months, perhaps even days. Supporters therefore describe AGI as one of humanity's greatest opportunities, a partner in solving challenges too complex for any individual civilization to address alone. Yet alongside hope comes profound concern, because history teaches another lesson. Every powerful technology carries unintended consequences. The more powerful the technology, the greater the responsibility required to govern it. Several influential thinkers have expressed concern about advanced artificial intelligence, though often with different emphases and different views about probability and urgency. Among them was the renowned theoretical physicist Stephen Hawking. Hawking frequently discussed both the extraordinary promise and the potential risks of increasingly capable AI. He suggested that sufficiently advanced artificial intelligence could become one of the most transformative developments in human history. But he also warned that if such systems were developed without adequate safeguards, the consequences might be difficult or impossible to reverse. His concern was not that machines would suddenly become malicious. Rather, it was that intelligence far exceeding our own might pursue objectives in ways humans fail to anticipate or control. Another prominent voice has been Elon Musk. For years, Musk has argued that advanced AI deserves serious attention because of its long-term implications. He has repeatedly called for thoughtful governance and safety research while also investing in AI-related companies and technologies. His position has sometimes appeared paradoxical. Build the future, but do not ignore its risks. The paradox reflects the broader tension throughout the AI community. Innovation and caution are advancing simultaneously. Perhaps the most striking warnings, however, have come from individuals who helped create modern artificial intelligence itself. One such figure is Geoffrey Hinton, widely recognized as one of the pioneers of deep learning. For decades, Hinton's research contributed significantly to the neural network techniques underlying today's AI revolution. In later years, he became increasingly vocal about the need to consider long-term risks associated with rapidly advancing AI capabilities. When one of the field's foundational researchers publicly urges greater attention to safety, people naturally listen. Not because he predicts a specific future with certainty, but because experience grants perspective. Why do some experts worry about AGI? The answer is often misunderstood. Popular culture imagines robots suddenly becoming evil, machines developing emotions, artificial intelligence deciding to conquer humanity. These dramatic narratives make compelling fiction. Researchers typically discuss something more subtle: optimization. Suppose humanity creates an AI with extraordinary ability to achieve goals. Now suppose those goals are specified imperfectly. The AI may pursue them with astonishing efficiency, but in ways humans never intended. Imagine instructing a super-intelligent system to maximize paperclip production. If the objective is interpreted literally and without appropriate constraints, the system might devote increasing resources toward manufacturing paperclips while ignoring everything humans actually value. The example sounds absurd. That is precisely why researchers use it. It illustrates that intelligence alone does not guarantee wisdom, nor does capability automatically imply compatible values. A system can become extremely effective at pursuing an objective without understanding the broader context humans care about. This leads directly to one of the most important scientific questions in artificial intelligence. Researchers call it the alignment problem. At first glance, the phrase sounds technical. Its implications are profound. Alignment asks a deceptively simple question: how do we ensure that increasingly capable AI systems consistently pursue goals that remain beneficial for humanity? The challenge extends far beyond programming. Humans themselves struggle to define universal values. Different cultures emphasize different priorities. Individuals disagree. Societies evolve. Ethical questions rarely possess one mathematically perfect answer. Now imagine translating these complexities into instructions understandable by a machine potentially more intelligent than its creators. The difficulty becomes obvious. Children illustrate a useful analogy. Parents rarely communicate values through one sentence. They teach gradually, they explain context, correct misunderstandings, encourage empathy, adapt lessons over time. Human values emerge through lifelong interaction. Artificial intelligence lacks this developmental experience. Instead, researchers must design methods allowing increasingly capable systems to behave reliably across countless unforeseen situations. This remains an active area of research involving reinforcement learning, constitutional approaches, human feedback, interpretability, oversight, and many other techniques. Important progress has been made, yet most experts agree that significant challenges remain. Another reason alignment matters is the possibility of rapid improvement. Human intelligence evolves biologically over generations. Software can improve much faster. If future AI systems eventually contribute to designing better AI systems, development cycles could accelerate. Some researchers refer to this hypothetical possibility as recursive self-improvement. Whether such scenarios will occur remains uncertain, but they illustrate why many experts advocate solving alignment problems before capabilities become dramatically more advanced. Building safety after deployment may prove more difficult than incorporating safety from the beginning. History repeatedly supports this principle. Bridges include safety engineering before opening. Aircraft undergo extensive testing before carrying passengers. Nuclear facilities emphasize containment before operation. The more powerful the technology, the earlier safety becomes essential. Importantly, concern about AGI should not be confused with certainty that catastrophe is inevitable. Many researchers remain optimistic. They believe humanity can develop increasingly capable AI responsibly through careful engineering, international cooperation, robust governance, and continuous safety research. Others remain skeptical that current AI architectures will naturally evolve into anything resembling human-level general intelligence. Scientific disagreement remains healthy. No consensus exists regarding timelines or ultimate outcomes. That uncertainty makes thoughtful discussion even more valuable. Perhaps the most remarkable aspect of the AGI debate is that it forces humanity to confront philosophical questions once reserved for fiction. What is intelligence? What is consciousness? Can reasoning exist without experience? Should advanced AI possess rights? Can morality be formalized? Who bears responsibility for decisions made by autonomous systems? Technology has transformed ancient philosophical questions into practical engineering challenges. Laboratories now explore issues once discussed primarily by philosophers. Computer scientists collaborate with psychologists, neuroscientists work alongside mathematicians, ethicists advise engineers. The boundaries between disciplines continue dissolving. If AGI eventually becomes reality, future historians may describe it as one of the greatest transitions in civilization. Not because machines replaced humanity, but because humanity created a new form of intelligence capable of collaborating in scientific discovery, education, medicine, engineering, and countless other fields. Or perhaps history will describe a different path. One marked by slower progress, careful regulation, and decades of incremental advances before anything resembling AGI appears. No one can say with confidence. That is the nature of frontiers. Standing at the frontier of artificial general intelligence, humanity faces a profound choice. Fear alone cannot guide innovation. Neither can blind optimism. Wisdom requires both imagination and caution, curiosity and responsibility, ambition and humility. The question is not simply whether we can build increasingly intelligent machines. The question is whether our institutions, our ethics, and our collective judgment can mature quickly enough to guide technologies whose capabilities may continue expanding far beyond anything previous generations imagined. The greatest challenge of AGI may never be creating intelligence greater than our own. It may be ensuring that our humanity grows alongside it. Because if the next great intelligence is born from human hands, its future will depend not only on the code we write, but on the values we choose to embed within it. Chapter 12, The Nature of Progress, Humanity's Lifeboat in the Age of Artificial Intelligence. Every great journey eventually arrives at a quiet moment, a moment when the excitement settles, when the headlines fade, when the noise gives way to reflection. Over the course of this audiobook, we have traveled through laboratories, corporate boardrooms, government policies, billion-dollar investments, scientific breakthroughs, ethical dilemmas, legal battles, and visions of a future that often feels both exhilarating and unsettling. We have witnessed Google's unexpected awakening after years of technological dominance. We have explored OpenAI's improbable rise from a nonprofit research laboratory into one of the most influential technology organizations in history. We have followed Microsoft's strategic partnership, Nvidia's extraordinary ascent, China's accelerating AI ambitions, the debate surrounding copyright, the transformation of the labor market, and the profound questions raised by artificial general intelligence. At first glance, these stories appear to describe a competition among companies. Google, OpenAI, Microsoft, Meta, Nvidia, Baidu, Alibaba, Tencent, each racing to build increasingly capable artificial intelligence. But beneath the headlines, another story has always been unfolding, a far older story, a far larger story, because this has never truly been about companies. It has always been about civilization. Every generation experiences at least one invention that permanently changes the relationship between humans and knowledge. The invention of writing allowed ideas to survive beyond memory. The printing press allowed books to reach ordinary people instead of remaining locked inside monasteries and royal libraries. The scientific method transformed curiosity into systematic discovery. The internet connected billions of minds across continents. Artificial intelligence represents another transformation of that same journey, not because it replaces knowledge, but because it changes how knowledge is accessed. For centuries, finding information required searching. Libraries, encyclopedias, search ends, keywords, links. Humans asked questions, then searched for answers. Today, increasingly, people simply begin a conversation. The interface has changed. The experience has changed. Perhaps even the way we think has begun to change. When future historians look back upon this period, they may not describe it as the age when better chatbots appeared. They may describe it as the moment humanity fundamentally redesigned its relationship with information itself. That transformation is far larger than any single company, far larger than any product, far larger than any quarterly earnings report. This realization also changes how we should think about the so-called AI race. Competition undoubtedly accelerates innovation. Companies compete, researchers compete, nations compete. Competition has produced extraordinary advances throughout history. Yet the true destination is not victory over competitors. It is creating tools that expand human potential. The companies participating today may not all dominate tomorrow. History rarely rewards permanence. The largest corporations of one century often become footnotes in the next. What endures is the knowledge created, the scientific understanding accumulated, the institutions strengthened, the wisdom preserved. Artificial intelligence should ultimately be judged not by the market value of the companies building it, but by the value it creates for humanity. Does it improve education? Does it accelerate medicine? Does it reduce suffering? Does it help scientists solve problems once thought impossible? Does it strengthen democracy, creativity, and human flourishing? These questions matter far more than market share. Throughout this audiobook, one concern has appeared repeatedly. Will artificial intelligence replace us? Perhaps that question was never the right one. History offers a different perspective. The printing press did not replace thinking. The calculator did not replace mathematics. The internet did not replace curiosity. Instead, each technology shifted which human abilities became most valuable. Artificial intelligence appears to be doing exactly the same. Routine knowledge becomes increasingly abundant. The ability to memorize facts becomes less valuable when accurate information is available instantly. But other abilities become more important than ever before. The ability to evaluate, to question, to connect ideas across disciplines, to understand context, to recognize nuance, to make ethical judgments. These are not merely professional skills, they are deeply human capacities, and they cannot simply be downloaded. Perhaps the most important skill of the AI age is no longer finding answers. It is asking better questions. This may sound surprisingly simple, yet history repeatedly demonstrates that great discoveries begin not with brilliant answers, but with extraordinary questions. Why do planets move? Why do diseases spread? Why does matter exist? Why do civilizations rise and fall? Artificial intelligence can generate thousands of possible answers within seconds, but deciding which question deserves to be asked remains a profoundly human responsibility. This is why prompt design has become far more than a technical exercise. A prompt is not merely an instruction typed into a computer. It is structured thinking, clear thinking, intentional thinking. The quality of an AI's response often reflects the quality of the human question. In that sense, AI becomes less like a replacement for intelligence and more like an amplifier of it. Those who ask shallow questions often receive shallow answers. Those who ask thoughtful questions frequently uncover entirely new possibilities. Critical thinking, therefore, becomes humanity's most reliable compass. Artificial intelligence can summarize millions of documents. It cannot relieve us of the responsibility to judge whether those summaries deserve trust. It can recommend, but humans must decide. It can generate arguments for opposing positions. Humans must determine which arguments withstand evidence. The age of AI may produce more information than any civilization has ever encountered. Ironically, that abundance makes discernment even more valuable. Wisdom has never meant possessing the greatest quantity of information. Wisdom means knowing which information deserves belief. Another uniquely human strength may become even more precious: empathy. Artificial intelligence can simulate compassion remarkably well. It can recognize emotional language, respond politely, offer encouragement. But genuine empathy arises from lived experience, from vulnerability, from relationships, from shared suffering. A physician comforting a frightened patient, a parent reassuring a child, a friend listening through grief, a teacher recognizing quiet frustration in a struggling student. These moments involve more than language. They involve presence. Artificial intelligence may assist these relationships. It should never replace their humanity. As technology becomes increasingly sophisticated, human connection may become increasingly valuable. Emotional intelligence also deserves renewed attention. Organizations once rewarded technical expertise above nearly everything else. Tomorrow's leaders may require something broader: the ability to collaborate across cultures, navigate uncertainty, resolve conflict, inspire trust, lead people through change. Artificial intelligence can optimize systems. Leadership ultimately concerns people. That distinction remains profoundly important. The future workplace may be filled with intelligent software, but every meaningful organization will still depend upon individuals capable of building confidence, cooperation, and shared purpose. Perhaps this reveals the greatest irony of the AI revolution. The more intelligent machines become, the more valuable distinctly human qualities may become: creativity, judgment, compassion, integrity, curiosity, humility. These characteristics resist automation not because machines lack computational power, but because they emerge from the richness of human experience. Technology changes tools. It does not erase humanity, unless humanity chooses to forget what makes it unique. There is another lesson hidden within the story of artificial intelligence. AI reflects us. Every model is trained on human language, human ideas, human discoveries, human art, human mistakes, human disagreements, human hopes, human fears. Artificial intelligence is, in many ways, the largest mirror humanity has ever constructed. When it produces beauty, it reflects beauty already present in civilization. When it generates misinformation, it reflects misinformation humans created. When it demonstrates bias, it often reveals biases already embedded within society. Machines do not emerge from a vacuum. They inherit the world we build. That realization should inspire humility. If we wish for better artificial intelligence, we must also strive for a better humanity. Better education, better science, better journalism, better institutions, better conversations. The quality of future AI may ultimately depend upon the quality of the civilization that teaches it. This is why the question before humanity is not whether artificial intelligence is inherently good or inherently dangerous. History rarely divides technologies into such simple categories. Fire cooks food. Fire destroys forests. Electricity powers hospitals. Electricity powers weapons. Nuclear physics enables cancer treatments. It also created the atomic bomb. Artificial intelligence belongs to that same tradition. It is a force. Its consequences depend upon governance, ethics, institutions, education, international cooperation, and millions of individual choices made every day. The future will not be determined by algorithms alone. It will be determined by the humans designing, regulating, deploying, and using those algorithms. That responsibility cannot be delegated. Perhaps the greatest lifeboat available to humanity is neither legislation, nor computing power, nor corporate competition. It is wisdom, the wisdom to innovate without arrogance, the wisdom to regulate without fear, the wisdom to compete without abandoning cooperation, the wisdom to recognize that intelligence alone has never guaranteed civilization's survival. History offers countless examples of brilliant societies undone by poor judgment. Artificial intelligence increases humanity's capabilities. Whether it also increases humanity's wisdom remains entirely our choice. As this journey comes to an end, one truth becomes unmistakably clear. The artificial intelligence revolution is not a distant future. It is not a prediction. It is not science fiction. It is the present. Every day, millions of people learn, work, create, communicate, and solve problems alongside increasingly capable intelligent systems. The next chapter of this story will not be written only by engineers in Silicon Valley, or researchers in Beijing, or policymakers in Brussels. It will also be written by teachers, students, doctors, artists, scientists, entrepreneurs, parents, and ordinary people who decide how these extraordinary tools become part of everyday life. The future of artificial intelligence is not waiting for us. We are creating it together, one decision at a time, one question at a time, one conversation at a time. And perhaps that is the most important lesson of all. Artificial intelligence is not the author of humanity's future. We are. The machine may become unimaginably powerful, but the direction in which it moves will always begin with the hands that choose to guide it. Closing podcast message. Thank you sincerely for spending your time with this audiobook. If you found this journey through the world of artificial intelligence thought-provoking, please consider supporting this growing channel by liking and sharing this episode with someone who enjoys exploring science, technology, and the future of humanity. Most importantly, we'd love to hear from you. Which idea in today's audiobook surprised you the most? And what topic would you like us to explore in our next long-form science podcast or audiobook? Leave your thoughts and questions in the comments below. Your suggestions help shape future episodes, and they inspire us to continue creating thoughtful, science-based content for curious minds around the world. Until next time, keep asking better questions, keep learning, and never stop exploring.